Well, good morning or good afternoon, depending on where you folks are tuning in from. Welcome to this webinar to review some of our coaxial driver products. For those of you who have possibly used some of our products before, maybe we'll discuss some that you haven't had an opportunity to use or less familiar with. Um, I can receive questions here via YouTube, so feel free to post anything that comes to mind. There's a little bit of a latency here of, I don't know, 15 seconds or so. And so just bear with me if your question is lagging behind, or my response is lagging behind any question. So um, off we go. Um, Fulcrum is unique in that we are the only manufacturer that offers a very wide range of products based on coaxial drivers. And we offer a number of products that are coaxial designs, not based on coaxial drivers. Those will not be covered today. We're really going to focus on our coaxial driver-based solutions. We cover a lot of territory in terms of product sizes and configurations and families, all based on coaxial drivers. So it can get to be a little bit confusing at times, and there's a lot of solutions available. Today, we will look at some of the core technologies that go into these solutions, help understand the differentiation between product families and product lines, specifically focusing on installation products. Uh, in the Prophile Series, the CX, the DX family, the GX family, and the RX family. Again, for folks who have had an opportunity to work with perhaps one of the product families, maybe this will help understand some of the other solutions that are available and widen your palette a bit. Just as a quick coaxial 101, a coaxial driver is a mechanical assembly that collapses a separate, in our case, compression driver and woofer into one unit, one physical unit, one acoustical unit. The benefits of this approach are that the alignment of the axes of the compression driver and the woofer result in improved spatial response. Since the high frequency and low frequency elements are inherently aligned, they remain aligned off axis as well as on axis compared to a system with offset drivers, a listener moving throughout the coverage pattern and outside of the coverage pattern will experience different distance relationships between the woofer and the compression driver or the tweeter. This results in anomalies in the response due to the different distances to the high frequency and low frequency element. This is solved in coaxial solutions, resulting in much smoother, consistent response. Physically, I think it's obvious that a coaxial based product can be much smaller, can also be lighter, and aesthetically, the compactness of size can be a big benefit in projects where visual intrusion is a concern. Much easier to integrate these very compact designs into difficult architecture or low ceiling spaces, etc. Um, the basic anatomy of a coaxial driver really hasn't changed fundamentally since the 1940s when Altec introduced some of the first coaxial-based designs on the market. Certainly with materials improvements and magnet materials benefits and um, uh, more creative design approaches, we've been able to improve the technologies available to reduce package size, reduce weight, and present a number of options based on coaxial designs. I think traditionally we've seen coaxial-based solutions in control room monitors, in stage monitors, all based on maybe one acoustical solution. Through modern materials and modern design techniques, we've been able to extend that to a very broad range of general purpose solutions rather than a small number of specialty solutions. So the basic concept of the coaxial driver in the form that we use is a compression driver that is essentially mounted to the back of a woofer basket and fires through the center of the woofer, um, much the same way that was done with the original Altec coaxial drivers. Um, so the concept is similar, but again, some of the materials advances, as you can see in the comparison photos here, allow us to create a much shallower assembly and also an assembly that has much better front to back alignment of the two acoustical elements, the woofer and the compression driver. And Larry, I do see your question, and we'll touch on that as we get a little further along. So basically, we're going to look at a few of the different coaxial driver tools that we presently use, and then go into them in a little more detail. So you see here, there's three drivers shown that are sort of representative of the different platform types that we presently use. And we'll talk about each of these and the product families that result. Um, Actually, I wanted to go to this slide first, so I apologize for jumping around. You did notice in the previous slide that while there are three different driver types, there are two sort of fundamentally obvious differences. One is that some of the coaxial drivers have horns mounted to them and others seemingly don't. The driver on the left here does in fact have a high frequency waveguide that you can make out under the dust dome there. You see it, the sort of reflective metal wide waveguide that's under the dust dome. And that just generally provides a wide dispersion pattern, very commonly used in a number of applications. The driver on the right is the somewhat unique approach that we use, where we actually mount a pattern control horn to the coaxial assembly. This allows us to create a number of different dispersion patterns depending on which horn we mount to the driver. The horn also helps keep high frequency energy off of the cone, resulting in better consistency from low volumes to high volumes. If you imagine the driver on the left really having two pieces to the high frequency waveguide, there's the metallic part that lives under the dust dome, and then the cone itself actually is an extension of that waveguide to a certain degree. So as the cone moves and moves more at higher volumes, that cone is actually modulating some of the high frequencies. Therefore, it's imparting a different character from low level to high level. The high frequency horn used in the right helps to reduce that by reducing the amount of high frequency energy that ends up at the cone itself. Generally speaking, we also use large format compression drivers to help blend the high frequency and low frequency response together. When we think of traditional designs with offset drivers, we think of crossovers that orchestrate a handoff between the high frequency and the low frequency element. Since we've created here a single acoustical source, our crossover works more to blend the high frequency and low frequency together with some overlap, and the large format compression driver helps us accomplish that. And one more sort of bit of under the hood technology here before we get into the product side, and that is the powering mode of our coaxial drivers. Remember, these are really two drivers that are collapsed together into one mechanical assembly. So they do have a separate high frequency element, a compression driver, and a low frequency element, a woofer, and they have two sets of inputs. We drive our coaxial drivers as a single electrical unit. Therefore, there's a crossover that's associated with the driver. The diagram shown here is a general schematic that's fairly typical for our coaxial systems. And you see it really is a very simple crossover. It only incorporates 4 elements, and that's because we only ask it to do the frequency dividing duty. We don't ask it to try to equalize the driver. This allows us to have a crossover that is very simple, a low parts count for high reliability, simple design for excellent sonic quality, and gives us the best of both worlds, the sonic benefits of bi-amplifying but with fewer amp channels. So this is a common element throughout all of the products we'll be looking at today. And so just keep in mind that we're always driving our coaxial products with a single amplifier channel. So the first product series we'll visit is the GX series, which is part of our TQ install product family. And these are all products aimed at the installation market with the variety of horn patterns, as discussed previously, that make them attractive to the installation, to the sound installer, to the integrator, to the designer. The GX series is based on coaxial drivers that use a ceramic magnet. And actually, this reminds me, I apologize for jumping around, but I did bypass one slide here that I wanted to come back to illustrate the 3 basic coaxial platform types. So I apologize for jumping around here, but it's my webinar 101 here. I'm not as fluent as some folks might be. So in any case, we have 2 basic platforms we discussed before, with horn or without horn. And then for the horn-based coaxial drivers, there's 2 different platforms we use. One uses a neodymium magnet structure for our CX, DX, and FX, RM, and FA product families. The other uses a ferrite magnet. The ferrite magnet's a little heavier, a little bit lower cost, and allows us to hit a slightly lower price point with some of the products that utilize it. The basic motor structures are the same for each, so it's the same cone, the same compression driver, diaphragm. It's just the magnet structure is the differentiating feature between the 2 coaxial drivers shown on the right here. And you can see on this chart the horn options that we have available for these different drivers. Now, every horn isn't offered in every product family, but these are all the horns that can mate with the different drivers. So the GX series uses that ceramic magnet driver that I was just referring to. 3-inch compression driver, diaphragm for high output, and again allowing us to blend the high frequency and low frequency elements together. Low frequency extension down into the 40 hertz range, which makes it a good general purpose tool. You'll notice that the general shape of the enclosure is trapezoid. It's a very familiar loudspeaker shape, and competes against other performance-oriented 2-way systems, but provides all the benefits of the coaxial approach. Offered both in a 12-inch version and a 15-inch version with a number of different horn patterns that are shown here. Sibling family to the GX is what we call the CX. And this was actually the first coaxial installation family that we created with the pattern control horns. This uses the neodymium-based coaxial driver, which allows it to work a bit better in a smaller enclosure. And as you can imagine, the enclosures that are shown here are quite compact, less than half the size of a conventional 2-way system using offset drivers. The CX series is offered in 8-inch, 12-inch, and 15-inch coaxial platforms. The available horn patterns are shown here. Either a 3-inch compression driver for the 12 and 15-inch sizes, or a 1 3/4-inch compression driver in the 8-inch size. The enclosures are vertically trapezoid here rather than horizontally trapezoid, which allows them to tuck up nicely against ceilings and really get out of the way of sight lines. A little bit less low frequency extension in the CX series due to the reduced enclosure volume. DX series is a step up in performance and output. Is sort of the bigger brother to the CX series. It starts with the same coaxial drivers available in 8-inch, 12-inch, and 15-inch sizes, and the same familiar horn patterns that we've had in the GX series and the DX series. But they add an additional woofer to the system, and the woofer is the same size woofer as the woofer used in the coaxial driver. So we have a double 8 version, a double 12 version, and a double 15-inch version. Low frequency extension and output are both increased due to the additional woofer in the system, but they're still very compact. Um, for example, the double 12, the DX12, which is the center image here, is similar in size to many competitive 12-inch two-way systems. So in the same envelope, we're able to add a second woofer and get a lot more low frequency output and increased vertical directional control. And I'll speak more about that in a moment because that's an important additional benefit from the DX series. The 12-inch and the 15-inch DX series require 2 amplifier channels. We use 1 amplifier channel to drive the coaxial driver, and then the second amplifier channel to drive the additional woofer. In the double 8, the DX8, that is only requires 1 amplifier channel. So here's an interesting view into both the crossover alignment and the resulting vertical pattern control benefits as well as output benefits from the DX series. So rather than using a conventional crossover alignment between the woofer and the coaxial driver in the DX series, we use a somewhat unconventional, sort of a 2.5 way alignment, if you will. So on the left diagram here shows you the coaxial driver response in blue and shows you the woofer response in red. And as you see, the coaxial driver is actually used all the way to the low frequency limit of the system, although the coaxial woofer is shelved down starting at roughly 300 hertz-ish. It depends, it varies from system to system. And then the second woofer is overlaid on top of the coaxial woofer at the low frequency part of the response. So using both woofers together in the low mids and lows gives us more bass output than we would get from a single woofer, but it also gives us this vertical directional benefit. So the graph on the right shows the difference between the single coax version, the CX1265 in blue, and then the double driver version, the DX1265 in red. And so you can see that the additional woofer does extend the vertical pattern control down quite a bit by at least an octave. So by using both woofers together, we get both an output benefit and a beam width benefit. And all of this can be seen in any acoustical modeling that you might do using ease, for example, and comparing the resulting patterns between, say, the CX series and the DX series. And Larry's asking about the DXFR. I think what he's referring to is full passive versions of the DX12s specifically. There are certain times where in large systems, for example, it's beneficial to be able to drive a DX12 system with a single amplifier channel rather than bi-amplifying it. And so we do offer that as an option with a full passive crossover. We call that the DX12 FP full passive. So that is a technique that's used from time to time when installations require either less wiring or fewer amp channels. So Larry, that is still available. Another view here of the same directional benefits of the DX versus the CX. What these graphs are showing is frequency response measured at different points off axis. And if you look at the difference in the vertical off axis response, the graphs at the bottom, you've got the DX system on the left and the CX system on the right. And you can see that the curves maintain their spacing, their spread to a lower frequency, which shows how we're getting the improved low frequency vertical benefit from the DX using the two woofers in that unique alignment. RX series is the smallest series that we offer in coaxial designs as part of that TQ install family, based on a 5-inch or 6-inch nominal coaxial driver. And these use true compression drivers, just like the other coaxial systems that we've discussed thus far. It's very unusual to find a coaxial compression driver based system this small. Most competitive products in this size format use just a woofer and a dome tweeter. We were asked to create these by a theme park customer of ours who was not able to achieve satisfactory results with compact dome tweeter-based systems and needed something that provided more articulate sound character at higher levels and maintain its character from low level to high level, which dome tweeters really don't do very well. So we created these in both a 5-inch and a 6-inch version. They've become extremely popular. Only one horn pattern, which is a 90-degree conical type of horn. And they're generally used for fairly near field applications. So that's a pattern that's well suited to that application. And these drivers are 16 ohm impedance, so they can be daisy chained for a number of units without requiring 70 volt distribution. That same technique is used in our 8-inch systems as well. Any of our single 8-inch coax-based systems also use 16 ohm drivers to allow multiple drivers to be paralleled without needing 70 volt distribution. And if you ever need to daisy chain more units than can be accommodated at the native impedance, we can always provide 70 volt transformers. The Prophile Series is the series that's built on the coaxial drivers that just use the waveguide approach, the wide dispersion, high frequency element. This was originally created for the club industry, the club users who needed very high output near field types of systems. And the wide waveguide helps accomplish that. And it also helps us to create very compact enclosures because we don't have to wrap grills around the horns, for example. So the enclosures are wrapped as tight to the drivers as we can. The grills are as tight to the baffles as we can. And the systems all provide generally high output, wide dispersion. Starting from the top image down, there's the Prophile P, which is an 8-inch system, again 16 ohms. The Prophile S, which is the 8-inch coaxial driver with a companion woofer. That is a single amplifier channel as well. And then the Prophile M, which is a double 12-inch system, which uses 2 amplifier channels. And then the double 15-inch Prophile L that uses the again 2 amplifier channels. One of our newer developments is combining both the compact packaging of the CX12 series with the passive cardioid that was developed first for the FL283 line array and then into some of our subwoofers. So this is a very unique combination of technologies that allows us to take a very compact system and a high output compact system and add an unprecedented amount of low frequency control by the addition of the passive cardioid technology. So the passive cardioid technology uses a unique series of acoustical networks built into ports that are, in this case, not actually visible in this view because they're on the top rear of the enclosure and bottom rear of the enclosure. This helps to reduce the amount of rearward low frequency energy fairly dramatically. So now in a very compact system, we can have a wide range of horn options coupled with a surprising amount of low frequency control. The CCX12, as we call it, is available in some of the same horn patterns we've been talking about. It uses that same neodymium-based coaxial driver with a 3-inch compression driver for high output, but once again incorporates the passive cardioid technique. And this just shows a bit of the improvement that we're able to achieve with the passive cardioid. So looking first at the right, the horizontal polar response, and you can see in blue is a CX1295. This is showing 200 hertz polar response. And the benefit, the incremental benefit of adding the passive cardioid, which gives about 9 dB of rejection behind the loudspeaker. So obviously that can be a big benefit in reverberant environments or any environment really where sound moving backwards is a problem. And in almost any installation, low frequency energy going backwards is not useful. So whether it's a loudspeaker that's mounted near a wall and the passive cardioid can reduce the amount of low frequency energy coming back off the wall, which then appears as a notch in the response when it combines with the direct energy. If it's a distributed system where the contribution of many distributed sources can decrease clarity and intelligibility, again, more control is better. Community noise issues for outdoor facilities where sound may be leaking out of a stadium seating bowl, for example. The passive cardioid can be very helpful to reduce sound going in the wrong direction. On the left here, you see the same information presented in the beam width view. And again, you can see the benefit of the cardioid response product in red versus the non-cardioid version in blue. And question about more woofer size options coming with passive cardioid technology. Passive cardioid has been extremely well received in all of the products that we've rolled out with it. So I will say that there's a number of new products that are under development, both in the full range variety as well as subwoofers. So stay tuned. Unfortunately, we don't have an Infocom this year, but we have a number of products that are on target for release around that time. This is a little bit of, I'll say, kudos to Rich Frembus, who manages all of the support materials for our products. And this is just to show you the range of support material that's available for all of our products, coaxial or otherwise. Data sheets are available on the website that show you pretty much everything you would need to know when working with any of our products. Amplifier recommendations and requirements, lots of data of impedance response, beam width response, frequency response, on and off axis presented in multiple formats, polar and otherwise, mechanical drawings for both the standard versions and weather resistant versions, brackets. Each product has at least a 7-page spec sheet that tells you everything you need to know. If there's anything you don't find on the data sheet, you can always drop us a note, give us a call. Design support for all of our products, coaxial and otherwise, ease and ease focus. We've always supported ease. We've started supporting ease focus around December of 2019. So all of our products are available now with ease focus models. For folks working in the BIM environment, Revit, SketchUp, and so forth, those models are now available as well, very recently, just released within the past several weeks. And through our website, there's support for AutoCAD, DWG, DXF, 2D, and 3D support there. So I encourage you to go to the support section of the website for anything you need in terms of product information, design support, so forth. DSP, as I mentioned early on, the crossovers that we use in our products are non-equalizing. We assume that DSP is going to be part of any modern performance-oriented audio system, so we support as many DSP products as we possibly can. I think this is a current list of manufacturers that we support in standalone processors, in amplifiers that incorporate DSP. Not only are we doing equalization, but we are using high resolution FIR filters to provide extremely high fidelity, extremely stable response from low level to high level, to manage the on-axis and off-axis performance of products. And that's a whole nother discussion about the DSP and the way we integrate DSP, but it's fundamental to everything we do. It's required for use with our products. And so we do our best to support as many platforms as we can. Again, kudos to Rich for all of the time he puts into matching filters from manufacturer to manufacturer so that you can expect extremely consistent results from platform to platform and from product to product. So if there's anything that you would like to know more about, you can drop us a note at the info email address. Give us a call. If there's anything here that we touched on that might be of further interest for a future webinar, feel free to send that along. We're sort of new to the webinar game here, playing a little bit of catch-up ball, but we're hungry for topics that might be of interest to folks. Hopefully this was helpful in understanding the breadth of our coaxial driver solutions and maybe gave you some exposure to some products you might not have otherwise known about and other solutions that may be available. So like I said, feel free to drop us a note, get in touch with us, and thanks for tuning in today. A question just came up about Dante or AVB into self-powered units. The answer is yes, there are plans. Beyond that, it's something that is in the planning stages, and we look forward to being able to update some of our powered products with these features. So thanks again, everyone, and see you on the interweb.